This video will look at SOL A.7, which has to do with relations and functions. Okay, so this is all of the different ways that you might see relations represented. You could have a mapping, you could have a list of ordered pairs, you could have a table, you could have a graph, you could even sometimes have an equation. Alright, and what you'd have to do with these is determine whether or not they are a function. So we need a definition for a function. A function is a relation that has a unique output for every input. In plain English, that means that the x values cannot repeat. Alright, so what that means is if I have a function, if I have some equation or some table, and I put in 2, if I get 4 out, then every time I put in 2, I have to get 4 out again. If I plug 2 into the equation and sometimes I get 4 and sometimes I get 7, that would not be a function because I have 2 different y values for the same x value. So let's go back and look. In a mapping, in a list of ordered pairs, or in a table, you're just looking for repeating x values. So if every x value is different in a mapping, they only have one arrow, that is a function. Alright, in a table, every x value has to be different. These are the same number with different y values, so not a function. Alright, here we have 2 twice, so not a function. Alright, then on a graph, you're doing what's called the vertical line test. So if I take a vertical line and I run it across my graph, it can only ever touch in one place. So that only ever touches that blue line in one place at a time. It never touches the blue line twice in the same spot. So this one is a function. Alright, if I look at these dots over here, whoops. Alright, these dots over here, if I run my red vertical line across, only touches one dot, but right there it's going to touch 2 dots at the same time, so that means that this one is not a function. Okay, with functions you're also going to be asked to find these things and define these things for each function. So the domain, remember, is all possible x values. And range is going to be all possible y values. So if we look at our different representations of functions, domain and range, so domain is x, range is y. If you were asked for the domain and range of these, you would just list the numbers. So the domain would be -4, -2, 0, 2, 4, and the range would be -1, 1, and 4. You're going to see them written in brackets like this, so it would be just a list. -4, -2, 0, 2, 4, and they would have brackets. So that would be the domain. Alright. You can also find domain and range from a graph, and there you have to look at, is there any limit to the value? So if I look at this graph, it goes left forever, it goes right forever, there's never any breaks in it. So I would say that x is all real numbers. Alright, and you can see that written a number of different ways. It might say all real numbers. It might say that x is between infinity and negative infinity. And then, like we talked about in class, you can use the symbols to say that x is an element of the real numbers. Alright, and it would be the same for the range. You would just list the y values, list every y in the ordered pair. Okay, if we look at a graph, you're looking at vertical, so does it go up forever, does it go down forever? This graph goes down forever, but it can only go up to 0, so I would have to say y is less than or equal to 0. That would be the range of that function. You also have to find x and y-intercepts. So remember, an x-intercept is going to be where the graph crosses the x-axis, and the y-intercept is going to be where it crosses the y-axis. These are going to be written as ordered pairs. Alright, and for an x-intercept, it's going to be some number, comma, 0. That second number is always going to be 0. And for a y-intercept, it's going to be the opposite. So 0, comma, some number, where the number is where it crosses the x-axis or where it crosses the y-axis. Alright, and then we also need to find solutions, roots, and zeros. But if you remember, these numbers are, these terms are also synonyms for the x-intercept. So the solution, a root, a 0 is also where the graph crosses the x-axis. All right. If you're given a graph, just look at the graph and find the number where it crosses. If you're given an equation, remember we showed you how to graph, and then on your calculator you can find the root or zero just by pressing a couple buttons. All right, remember you're going to type in the equation, so I just came up with an example here. And then if I want the zeros, I'm going to draw it. I'm going to do gsolve root, and there's my roots, my solutions, my x-intercepts, -3, 0, and 1, 0. And we can do the same thing with a linear function as well. So 2x plus 4, like those lines we graphed at the beginning of the year, I can find an x and a y-intercept. If I do gsolve root, it's still going to give me the x-intercept, -2, 0. And if I do gsolve y-intercept, it's going to give me the y-intercept. So most of these can be done either by looking at the graph or just graphing it and getting the calculator to do the work for you.